Hey guys, and welcome to this coding problem video. In this one we are going to be solving a problem called the H-index problem. Now, what is actually the problem? So in academia, the H-index is a metric used to measure the impact of a researcher's paper. A researcher has index H if at least each of his or her n papers have H citations each, and if there are multiple solutions satisfying the condition, then the maximum is chosen. This is an interview question asked by Palenti, and then they proceed by giving us an example. Suppose a researcher has n equals 5 papers, and the respective citations are 43015. Then the H index of the researcher is 3. Now it is defined. We say up here that the H index is H if at least H of his or her n papers have H citations each. So what we are asking here is that we just have to look for a number amongst the citations, a number H, and then we are going to count the numbers amongst the citations which is made up of that number H. For example, in this case, let's try to find the H index. What we basically have to test is whether the number is greater than or equals to the number we have selected. So for example, if we begin and we select 4, then we are going to try to compare 4 with all of the elements inside this list of citations. So we are going to take 4 and compare with 4, and it's good we keep in mind a variable count to get to know the number of counts that a variable or in a citation has satisfied the condition. So let's say we have a variable count, and then we're trying to know the H index of this researcher. So we're going to take this the number 4 as H, and then we're going to compare with all of these numbers in this list, and Y, and every number that satisfies the condition, we're going to increment the count to know the count of numbers that satisfy the condition. So let's take 4. We compare 4 with itself, with the first element, which is actually 4, and you see that it is equals to 4, so we increment count. We found one number. Let's compare with 3. It is less than 3 and it does not satisfy the condition. 0 doesn't, 1 doesn't, but 5 does. So we have 2 numbers inside this list of citations that satisfy the condition, but we have to have each number of citations that satisfy the condition. So in order for 4 to be a possible H index for the researcher, there should be 4 numbers inside this list of citations that actually satisfy is greater than or equals to 4. If we take 3, we have 4 which is greater than 3. 3 is equals to 3, and then 5 2. So we have 3 numbers which are greater than or equals to 3, and therefore the H index of this researcher will be 3. Now let's write a function that is going to will be able to calculate the H index of a researcher. So we're going to call that function find H index, and that function is going to take a parameter which should just be a list, and that function is going to return to us an integer. Now note again that there could be many solutions to this that will satisfy the H index of a researcher, and in that case we are going to take the maximum. So we are going to create a list called possibilities that will contain the possible solutions of the H index of this researcher, and we're also going to keep in mind a variable called count to count the number of citations inside this list, the number of research papers inside this list that satisfy our condition. Then for we are going to loop, because we are going to try comparing with each of these numbers. So we are going to take the first number, loop through the whole list once more while counting, and if it satisfies, and if there are that number, that first number in the list, count of numbers inside this list that satisfy the condition, then we add it to our possibilities. So we're going to create a loop. We are going to loop between the elements inside the list, and then for each element that we take inside the list, we're going to loop a second time just to compare, and then we're going to compare if that element is greater than or equals to the number, so the element that we have selected, the element we are currently working with. If it's satisfied, then increment the count, otherwise we just proceed. And then if the count, so if the count equals to the value of count equals to that element, and therefore it is a possible solution to the h-index of this researcher, and therefore we can add it at the end of the list. Otherwise we can still pass. Don't forget to reset the value of count to make sure that every time we restart with another loop, we are restarting from a clean slate. Then we are going to return the maximum solution inside this inside the possibilities. Now let's test our solution. So I'm going to print find h-index, and we're going to test it against the sample given to us. And then we see that we get the answer 3. Now let's try again with something a little more complicated. I know a list with greater number of research paper citations. So we are going to record that list sample, and inside we're going to put 4, 2, 8, 3, 1, 7, 3, 6, 4, 8, 4, 5. And this time let's test using this list to get the h-index, and we see that the answer is 5. Now let's try by ourselves to see if 5 is actually the correct answer. So the program, this function, says 5 is the h-index of this researcher. So let's try that. We see 5. Let's have count equals 1, because actually 5 satisfy the condition. Let's go to the next. It means we have 2 numbers that satisfy the condition. We see 6 is also greater or equals to 5, so that's 3. 7, that satisfy the condition too, so that would be 4. 8, yeah, that also satisfy the condition, so that's 5. It means we found 5 elements, 5 research papers that satisfy the condition that is actually equal to the number h chosen, and therefore this number 5 is the h-index of this researcher. I hope you really liked this video, so we are going to end here.